COC linkage generally we call what? Ether linkage. Or generally we write, no, here carbon, here carbon. What is the molecular formula? General formula will be like CnH2n plus 2O. This is the general formula here. CnH2n plus 2. You can also write like this also, CnH2n plus 1 O, CnH2n plus 1. CnH2n plus 1 means R. CnH2n plus 1 means RH. Okay. Generally we use this formula, CnH2n plus 2 OH. Now when you observe ethers and alcohols, monohydric alcohol which are having one OH group, we have same molecular formula. So CnH2n plus 2O we can use for alcohols, or we can also use what? For ethers. What is the reason why? Because both are functional isomers. Functional isomers will have same molecular formula, but their functional groups will be different. Same molecular formula, functional groups will be what? Actually different. Actually, functional groups will be different. Right? So for example, you take this ethyl alcohol, the general formula is CnH2n plus 2O only. C2H6O. Okay, CnH2n plus 2. But this functional isomer will be what? Actually I am writing C2H6O. General formula is CnH2n plus 2. For this one also same formula. Same formula here. Why? Because alcohol and ether both are actually what? Functional isomers. This is important thing you need to remember. Actually. When you say the name for what is the option? Ethers are derivatives of alkenes of. Which one is correct, madam?
Both A and B.
Alkoxy and aryloxy will be the correct answer here. How you represent ethers?
A.
B. Alcohol. No, this is for alcohol. This one is for ether. This one is for carboxylic acid. This one is for esters. Which are functional isomers here? Ether are functional isomer with what?
Aldehyde.
Monohydric alcohol.
अभी आया आपने अभी ज्वाइन किया आपने monohydric alcohols which are having one OH group, only one OH you are having. Tri will have two OH groups, CH2OH. This is what dihydric alcohol. This is what CH3CH2OH. This one will have monohydric alcohol. What is the general formula? CnH2n plus 2O. Now when you observe ethers are two types beta. One is what? Simple or symmetrical ether. Second one is called mixed ether or unsymmetrical ether. Simple means what happened? Either directions are having same groups actually. R and R. These are what? Same. R equal to R here. In this case, what happened? R dash. R not equal to R dash. In this way, isn't it? You can write actually. Both alkyl groups which are attached to oxygen is same. And here it is what? Different. Right? We'll take one example here. You observe here. Both alkyl groups are same. In this case, both alkyl groups are different. You see, this is methyl. This one is what? Methyl, isn't it? Methyl ether or methoxy. I will do. We'll take IUPAC nomenclature in the next slides. Okay. So what I mean to say is that mixed ethers, simple ethers. Difference you have to identify. Right. Next. This is the isomers of ethers, like a chain functional isomers, metamerism that we see. Metamerism is something important for us. Remaining chain isomers means arrangement of atoms is different here. This you can also write like this also. You can also write. That means these 4 carbons can put in one straight chain. The remaining we can write on the outside. Okay. But the number of carbons here, how many? 1. Here 1. Here how many carbons here? 4. Here how many carbons? 4 carbons. Right. So this is called chain isomerism. Next, functional isomers, if you observe what happened, yesterday ethers and alcohols are functional isomers. Already you know this. Metamerism, let me see here, metamerism. I have taken diethyl ether. This is called diethyl ether because here it is ethyl and here also what it is ethyl. Diethyl ether it is. Now here how many metamers it can form? This is important for us. How many metamers it can form? Metamers means what actually? The number of carbons on either side different, but their molecular formula will be same. Now you observe here 2 carbons are there. In this side, how many carbons? 2. Here how many carbons are there, beta? Here how many carbons are there?
1.
Here how many?
4.
3.
Now these 2 are metamers because their number of atoms in either side were different. Right? 2, 2 and 1, 3 is what different. Isn't it? What about this one? It is having what? 1 carbon, 3 carbons. And it is, now if you observe what happened, these 2 will be definitely metamers. Correct? And these 2 must be metamers. And these 2 already complete. These two, they may be considered as a chain isomers, right? They may consider as a chain isomers because here 3 carbons are there, here 3 carbons are there. They consider as a chain isomers. Understood? Metamerism.
Yes, sir.
Now you can write many number of examples with this one. Okay, you take what like this: 2 carbons here, 2 carbons, 1 carbon here, 3 carbons like this, isn't it? Now this is which type of isomer, beta? Example of which one? Mixed or symmetrical? The 2 carbons mixed ether or unsymmetrical also we can call, no? Unsymmetrical ether also we can call because you can't cut into equal parts. Symmetrical or you can cut into equal parts. So both B and C we can give, right? Because you cannot cut into equal parts. Which type of isomers these 2 are?
Functional.
Only one is saying, remaining one. Ethers having same molecular formula but different alkyl groups in either side of oxygen. What is the name of this one?
Metamers.
Metamers.
What is the answer for this one?
Simple ethers or symmetrical, both A and C.
Symmetrical ethers also we can call this one. Now let me see important thing, nomenclature. Let me see. This is important for you. Now first structure, common name. How to give the common name, beta? Very simple. Now you have to call this one what? Methoxy, correct?
Yes, sir.
Here this is methyl group, correct? And this one also methyl group. So how many methyl groups are there here? 2 methyl. Therefore dimethyl ether you have to call. Simply what is it? Dimethyl ether it is. Simply you have to call dimethyl ether. Now how to give the IUPAC nomenclature? One part is alkoxy, other part is alkane. 2 parts you have to divide. Now if it is symmetrical, no problem for us. This is symmetrical. Okay, simply ether, no problem. We can cut easily. Now this part you take as a methoxy. This part you take as what here? Methoxy. This part is methoxy. And this part you take as a alkane. Alkane means nothing but what? Methane. Methane. Right? So you may get doubts. It is a methyl group. No, why you are calling methane? Because you are taking this group as what? Alkane group. You are taking this group as an alkane here. So what you have to call here? Methoxy methane. Methoxy methane. Isn't it? In this way, you write in your notebook after the class or what? Now also no problem. This is a very, very important nomenclature. When you're doing what exercise, what happened? You have to go according to nomenclatures. Now let me see now here. This one is methyl. This one is what? Ethyl. So what do you have to call this one? Ethyl, methyl, ether. Alphabetically we have to use ethyl, methyl, ether. So ethyl, methyl, ether it is called. Isn't it? Ethyl, methyl, ether it is called. Now a simple thing, no, a common name is very, very simple. But IUPAC nomenclature, how to select IUPAC nomenclature? All of you please listen. This is very, very important one. If you remember it carefully, what happened is. Now, which part is what having more number of carbons?
Ethane, ethyl.
Now, this part should have more carbons, right? Should have more carbons. And alkoxy group should have what? Less carbons. This we have to follow, correct? Now, this is having less number of carbons. Now, this part is called alkoxy. Alk means how many carbons are there? Only one carbon, methoxy. So, in the place of alkoxy, okay, in the place of alkoxy here, in the place of alk, what I am taking here? Meth. Now, here, this part, two carbons are there, ethane I am calling because alkane, alkoxy alkane, alkoxy alkane. In the place of alk, I am using what? Ethane. So, name will be called. Here, no need alphabetical order anything. Simply you have to call alkoxy alkane. Alkoxy is methoxy, alkane is what? Ethane. So, methoxy ethane you have to call like this. Isn't it? If you follow this rule, what happens? We can n number of examples we can write. If you observe which one, here ethyl group, here ethyl group. So diethyl ether, it is simple thing. Diethyl ether. Now what about IUPAC name? Anybody? IUPAC name?
Ethoxyethane.
IUPAC name very simple because both are having same number of carbons. Ethoxy ethane it is. For this one, common name is very simple. This group is propyl group. This group is methyl group. So propyl methyl ether, isn't it? Propyl methyl ether and methyl and propyl ether because it is having what state chain. N we are using because it is state chain. Okay, that is not no liquid. We simply call methyl MnOP. M will come first, no? M will come first. So methyl propyl ether it is. IUPAC name. How to give IUPAC name here?
Methoxypropane.
Methoxy. Large part is called what? Propane. So now we got an idea actually. Okay. Now it is called what? Methoxypropane. No problem. We can call this one as a methoxypropane. Now when you get this one, now we get it. This is also what actually? Methoxypropane only. But common name, if you observe what happened? Methyl isopropyl ether. Isn't it? Methyl isopropyl ether, but alphabetical order will come under like I and M. This isopropyl, second carbon is having what here? Methyl group, isopropyl we can call. So very important structure it is. Isopropyl methyl ether. But what about the nomenclature? IUPAC nomenclature. You can't call this one methoxypropane. You can call methoxypropane, but that is also there, no? Yesterday, just previous slide also is there. Methoxypropane. Now in this case, what happened? You give numbering for the alkane. This part should be given numbering. This part we should give numbering. Now we can give numbering from this direction. 1, 2, 3. Now again, alkoxy alkane only. Methoxypropane only I am writing here. Methoxypropane only we are writing. But number we are giving here. Number we are giving here. Isn't it? You observe your number we are giving. On which carbon methoxy group is there? 2 methoxy. Isn't it? Now what is 1 methoxypropane? CH2, CH2, CS3, OCS3. Now this is called 1 methoxypropane and this is called what? 2 meth. I'm also write like this also. OCS3. Okay. This is 1 methoxypropane. This is what? 2 methoxypropane it is. Understood here? Any doubts you are having in 4th and 5th?
No, sir.
No doubt, right? Now this one, if you observe, this is tertiary butyl, correct? This one is called tertiary butyl. This one is called what? Methyl. Therefore, tertiary butyl, methyl, ether. Correct or not? Tertiary butyl, methyl, ether. Common name. What about IUPAC nomenclature? Anybody IUPAC nomenclature?
2-methoxybutane.
Oxybutane. Or this one, again, tell me the answer now.
2-methoxybutane.
2-methoxy, 2-methyl propane.
Very good. 2 because 2 is having One is methyl as a substituent, methoxy as a substituent here. So what you have to call here? 2-methyl, 2-methoxy-propane, isn't it? 2-methyl, 2-methoxy-propane. Actually, what happened? You have to follow the IUPAC nomenclature. No. So meth, okay. Okay. Meth, okay. After meth, next word is what? Y. Next word will be O. Which will comes first? O will comes first. Actually. That is the reason what happened. Y will come next. So this will be second. This will be 1. According to alphabetical order. Therefore, what called 2-methoxy, 2-methyl-propane. Correct. This one is called what? Similarly, generally we call methoxybenzene. But common name, if you observe what happened, anisole we call this one. So remember, this one is what? Anisole we have to call. Anisole. IUPAC name is methoxybenzene. Simply we can call what? Methoxybenzene it is, isn't it? Methoxy. This is a methoxy group. This one is a benzene. So methoxybenzene or anisole generally we use. Anisole is very, very. Otherwise, what happened? Methyl phenyl ether. That is also we can call. This is a methyl group. This is a phenyl group. Totally it is called ether. This is called phenol, isn't it? Phenol it is called. Phenol you are calling this one. Or what happened? Ethyl phenyl ether. But ethyl phenyl ether generally we don't use. Generally we use phenol. And what is about this one? Ethoxybenzene. This one. IUPAC name will be ethoxybenzene, isn't it? Can you give now an answer for this one?
Alkoxyalkane. A.
Alkoxyalkane. Very good. What are IUPAC name? Just now we discussed now.
2-methyl, 2-methoxy-propane.
Is correct, better?
Ethoxybenzene.
Ethoxybenzene. Now let me see the physical properties here. Let me see the physical properties. Now when you observe the boiling points here, when you observe the boiling points of ethers boiling points are slightly higher than the alkanes, but much lower than the alcohols. What is the reason if you observe? I'm taking something, one example, CH3, CH2, CH3 I'm taking. Okay. And I'm taking what? One more CH3O, CH3 I've taken. Another one I've taken CH3, CH2OH. So 3 examples I've taken. This one is alkane, nothing but propane. This one is ether, nothing but what? Dimethyl ether. This one is alcohol, ethyl alcohol. Now here we can't develop any. Can you develop any charges here on a alkane? Can you develop any charges? Is it possible? So the charges here, what happened? London forces or van der Waals forces. Van der Waals forces operate. Correct? Here you can operate at least what happens, some poles you can generate here. Okay. So we can generate what happens, some dipole, because here negative charge, here is something what positive charge. A slight dipoles you can generate here. Slight dipoles actually. But here what type of bonding you can form here? What type of bonding you can form here? What type of bond you can form, beta? Hydrogen bond. So hydrogen bonding is stronger than the dipole forces here. So that is the reason what happened. Ethers are having intermediate properties between alkane and alcohol, isn't it? Which are higher than the van der Waals forces. The dipoles of ethers are higher than the dipole van der Waals forces and smaller than what happened? Hydrogen bonding here. So that is the reason the boiling points of ether you have to place like this, increasing order like this. Next, ethers are immiscible with water because they cannot form any hydrogen bond. Is it possible? Hydrogen bonding is not possible. Because of what? One more thing, you may get something like this, CH3O, CH3. This can form some little bit solubility will be there. Slightly soluble with hydrogen bonding. Like slightly hydrogen bonding is possible like this. Slightly hydrogen bonding is possible like this with water. But because of actually both, if you have hydrogen like ROH, water, both are having what? Hydrogen, then the hydrogen bonding is with very more hydrogen bonding you can get. Right? So here what is happening here because of alkyl group C. This is actually what hydrophobic part. Hydrophobic part. So that is the reason what happened as structure increases, the size, the chain of the carbon is increasing. What happened? The solubility further decreases. So generally what happened? Immiscible with water because of absence of hydrogen bonding, and also what happened because of hydrophobic nature of what? Alkyl groups. Right? Dipole moment of ether generally what happened 1.18. So that is the reason what happened. They taken as a solvent. Generally they taken as a solvent. And most of them are volatile and highly flammable also. That is the general property. Users, if you observe what happens, solvents generally, I told you just now, it is used as a solvent for the making of these compounds. The making of Grignard reagent. I given one Grignard reagent reaction, RMGX reacts with, isn't it? Sorry. Preparation of Grignard reagent. RX react with magnesium in presence of which solvent beta? Anybody remember? Which solvent?
Dry ether.
Dry ether we are taken. Dry ether. So in the see that is nothing but solvent here. So solvent used in the making of what? Grignard reagent. Used as a refrigerant and a mixture of diethyl ether and ethyl alcohol known as a natellite. Generally for what happened used as a fuel actually. Isn't it? Substituent for the petrol. We don't have the petrol. We can use diethyl and ether and ethyl alcohol. It is called what? Natellite. So this is about some uses actually. This is crown ether. Generally, we call this one. The name of this one is this is not in the syllabus. You haven't have the syllabus. So leave it this one. Crown ethers because ethers are forming some rings like this. They call crown ethers. There is no need for you. Leave it this one. Already we discussed. This is the preparation methods now. Very important preparation methods like this. So first preparation method, if you see what happened, first preparation method, you have now with NCR textbook now. Just open that textbook, all of you. Williamson synthesis reaction. Let me see now. There are generally three methods are there for preparation of ethers. The first preparation method, let me see now here. It is Williamson synthesis reaction. This is the way of reaction writing. So this one very simple here. You ought to writing here. One is sodium alkoxide. One is alkyl halide. So NaX will be removed. You are going to get the ether like this. So I am writing one example here. See, CS3 sodium methoxide reacting with what? Some alkyl halide, methyl iodide or iodomethane. Now what we have to remove? Remove the sodium iodide. We are going to get what actually? Now these two will be joined here. So you are going to get actually dimethyl ether action. Very simple or not? Williamson synthesis reaction. But some exceptions are there that are very, very important in examination point of view. For example, I want this one.
Sir, can you please repeat it?
No problem. Now, how do you get this? How do you get this? Right? In this case, two things we have to mention here. Now, I told you now in the last slide what you have taken here. One is alkoxide, other is alkyl halide. Correct or alkoxide? Other is alkyl halide. So two things are there here. I will show this one. CS3 ONA plus this part I am writing chlorine. You can take any halogen. CS3. Right? NaCl is removed. Now these two are joined here. You got this compound. Right? One more I am writing here. Here also what happened? NaCl is removed. Now these two are joined here. Now you got CH3, CH2, O, CH3. Both you got same product only. So for getting what? Ethyl methyl ether. For getting ethyl methyl ether. For getting ethyl methyl ether, what are the combinations we have taken? Sodium methoxide, correct or not? Sodium methoxide plus ethyl chloride. Any halide you can take. Ethyl chloride, ethyl bromide you can take. Ethyl iodide also, except chlorine, we can remain chlorine, bromine, iodine you can take it. Ethyl chloride. One combination. Second combination for getting ethyl methyl ether, sodium ethoxide. Sodium ethoxide. Plus what happened? Methyl chloride. Methyl chloride. Correct? Now for what I mean to say is, man, that means I can put X, the chlorine here. Okay. I can put what happened? Chlorine here also. I can put here what happened? ONA here, or I can put ONA here also. Like this also we can do. Like this also we can do. Two combinations we are getting. Two types of combinations we are getting. But main thing is that what are the reactants we are taking? Sodium alkoxides and alkyl halides. So what is the Williamson synthesis reaction? The reactions in which when sodium or potassium alkoxide reacts with alkyl halides to give ethers is called what? Williamson synthesis reaction. You can write any reaction here, like this. You can write any reaction like this. But which is what? Yield very good. Which one yield high percentage? In which method? Which percentage? That means if I take ethyl chloride or methyl chloride, which will give more yield actually? That is important for us. You see that. All of you understood what is Williamson synthesis reaction?
Yes, sir.
Any doubts you're having to write Williamson synthesis reaction?
Sir, in this, no reagent is involved.
No need, no reagent is no need actually. Directly the reaction takes place. No need any reagent in this case. Solvent is required, but no need for it. Just you simply write alkyl halide. Actually, alkyl halide, if you take reagent, but remaining will be reactant only. Right? Now, the thing is that here what happened? I want to prepare like this. This is we'll discuss later this one. This is not at all important now. Let me discuss this one. It's very, very important for you in examination point of view. This is important for you. You have to concentrate here like this. Now I have taken like this tertiary butyl bromide. One is alkyl halide, other is what? Alkoxide. Okay. Now what happened here? The bromine and sodium will be removed and this will be joined over here like this. Right? Now otherwise what happened? Let me do right like this. CH3 Br, write down this reverse way. Sodium O C2H5. Nothing but CH2CH, ethyl group it is. NaBr is removed. Correct? Now you got this product. You should get this. Which product you should get actually? This product. CH3, 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 and OC2. You are expecting this product, correct or not? This product we are expecting actually. Tertiary butyl, ethyl, tertiary butyl, ether we are expecting. And this will be minor product. And you are going to this one will be major product. It's a Williamson synthesis reaction. Whatever is we discussed in the last slide, you have taken two combinations there. But here if I take that combination, we are getting that one as a minor product. Understood what I am saying here? This we are getting major product. What is the reason? This is the elimination reaction. We will discuss later this one. Nobody asked this one, leave it this one. Now, why this is minor product? Now, what is the reason? Why you should get major product? In that case, what happened? The alkoxide, whatever the alkoxide must be bulk group. So, when you are making this type of product here, when you are writing what Williamson synthesis reaction, the alkoxide must be what bulk group. This should be bulk group and this will be small group. The alkyl halides, no, they should be smaller. So now how you can convert this one? Like this. CH3, CS3, CS3. Now in the place of bromine, what you write? ONA you write. Plus bromine, isn't it? CH2, CS3. Now NaBr will be removed here. Now definitely you are going to get this product. Now it will become now here what? Major product. Now it will be major. So how to get the Williamson synthesis reaction? So what we have to remember, to get alkoxide must be bulk group, alkyl halides must be smaller group here. If you remember this one, what happened? We can do n number of examples. Alkyl halide must be what? Smaller group. This must be what? Smaller group. This must be what? Larger. Understood?
Yes, sir.
That means when you get bulk group, definitely there should be secondary, tertiary alkyl halides. In that case, what happens? You will get alkene. You see, this is what tertiary alkyl halide. That means whenever you take what? Primary, no problem. When you take secondary, tertiary, then bulk groups will be there on the alkyl halides. So it will lead to elimination reactions. Correct or not? Now we'll see what happened. This one we need to see now here. This part, preparations of ether, Williamson. Now you having textbook with you, no? Now observe this one. Williamson synthesis reaction. Now this is the alkyl halide. You have taken alkyl halide, reacting with sodium alkoxide. This is the sodium alkoxide. Na is removed, X is removed. Now they join together like this to form ethers. Now in this case, the limitation we discussed, you observe. Now alkoxide is bulk group. Yes, bulk group is must be alkoxide. This should alkyl halide must be small group. Now you got ether, correct? You got ether as a major property. But here what they taken actually here? Alkyl halide, small group they taken, bulk group they taken, alkoxide they taken what? Small group. This is not reverse actually. So in this case we don't get what? Ethers are what? Minor products. These are what? Minor products actually. Very minor products. Now what product we are going to get here? Alkene we are going to get. Okay. So this is the exercise if you observe what happened. Exercise if you observe what happened. 11.6. Following is not appropriate reaction for the preparation of tertiary butyl ether. This reaction. What would be the major product of this reaction? Alkene. Isn't it? Alkene. This one. Just now you have taken this one. I will write the mechanism for both one. No problem. Okay. Now which is a suitable reaction for the preparation of tertiary butyl ether? Now this one. Alkoxide must be what happened? Large one. Like this. Okay. So this solution, this exercise you do in notebook. Okay. All of you do this exercise in notebook because very, very important in examination point of view. So do this 11.6 your notebook today itself. Okay. Right. Now this one, just now I think we have started this one only. I will explain this one. No problem. Whenever phenol react with sodium hydroxide, what we are going to get? When a phenol is reacting with sodium hydroxide, neutralization reaction takes place. Now what happens here? H plus OH minus will remove. Now we are going to get the ONA. Right? Now this is the phenoxide. Just like alkoxide, phenoxide also undergo reaction. Now I have taken what something alkyl halide. I am taking CH3 Br. I am taking alkyl halide. I am taking. Now what happened here? O minus attacks on carbon. Br will be removed and NaBr minus NaBr is removed here. Now we are going to get here what? OCH3. That means in examination, how do you convert phenol into anisole? In this way they ask us. How do you convert phenol into anisole? This is anisole. This is called anisole. And this is called what actually? So conversion of phenol into anisole. Now directly if they ask what happened, you will get many doubts. But if practice in this way, what happened? You can easily find out. Phenol, first you treat this sodium hydroxide, you get phenoxide, and phenoxide treated with what? Methyl bromide to get the anisole. Now, what type of reaction it is? That one also let me see now. What type of chemical reaction it is? Let me see that one also. What type of chemical reaction? Let me see now. Now, when you observe here what happened, CS3, CH3, ONA, a small example I am taking, right? Now, reacting with what? CS3, CH2Br. Okay. Now, what is happening here? Now, first of all, this bromine will be removed. So now what we get here? CS3, CH2 plus we get. Then this nucleophile attacks here on the carbon. So we are going to get CS3, CH2, O, CS3 plus Na. In this way, the reaction is. Now it's called what? Nucleophilic substitution reaction. Nucleophilic substitution reaction. Nucleophilic substitution reaction. SN1 or SN2, that depend upon what actually? It is SN2 mechanism. Most probably it is SN2 mechanism. SN1 will not take place. If it is SN1 reaction, elimination takes place, right? So definitely it will be SN2 mechanisms, isn't it? Right? Next, we'll see one more preparation method. This one. This by dehydration of alcohol. By dehydration of alcohol. Now, when alcohols are treated with what? Sulfuric acid. Okay, when alcohols are reacted with sulfuric acid, or you take phosphoric acid, most probably what happened? Sulfuric acid. You get two products. One is alkene, other is ether. That depend upon the temperature. If you maintain 443 Kelvin temperature, 443 means around what? 170 degrees Celsius. Okay. But if you maintain what happened? 413 Kelvin temperature. 413 means what happened? 140 degrees Celsius. Correct? Isn't it? One is what? 170, other is what? 140. So when you maintain what? 140 degrees Celsius, you are going to get the ether. This one. Ether you are getting. What temperature you are maintaining here? 140 degrees Celsius. If you maintain 170 degrees Celsius, you are going to get the ether. This is already we discussed or not? In the chemical properties of alcohol, I have completed this one. Correct or not? With mechanism also. We have discussed, including with mechanism also, we have discussed. Alcohols, how do they convert into ethers? We have completed this one. Now at 140 degrees Celsius, what happens here? You are getting ethers. How? Let me see now here. How ethers are forming also, let me see with mechanism. Now I will make a mechanism here in this paper I will make. Here let me see the mechanism. At low temperature, 140 degrees Celsius, I told you, we get ether. So I'm taking here what? CH3, CH2, OH. First it react with what? Acid like this. Concentrated H2SO4. At what temperature? 140 degrees Celsius or 413 Kelvin temperature. Now this will give H plus to this oxygen. It is giving H plus to the oxygen. Now what we are going to get here? OH2. Positive charge on oxygen. Correct or not? Understood? Everyone? This part? Protonation. Understood or not?
Yes,
Yes,
sir.
sir.
After this, what happened here? You take second mole now. Second mole. Again take one more mole. CS3, CH2OH. Now it has some nucleophilic character because of lone pair. What happened? Attacks on the carbon side. Now water will be removed here. Minus H2O will be removed here. Now we are going to get the CH3, CH2. I am writing this one OH like this, and CH2, CH3. Now because of lone pair of oxygen given to carbon, no, so oxygen will get a positive charge here. But the electrons present between oxygen, hydrogen taken by oxygen here. Now hydrogen released as H plus here. Now you have added H plus here. Now you are removing H plus here. Acid catalysis reactions it is. So finally you are going to get the CH3, CH2, O, CH2, CH3. So this is the mechanism. There are two mechanisms are there. First mechanism for getting alkane at 170 degrees Celsius that we discussed in the properties of alcohol. Go through that one. Second mechanism at 140 degrees Celsius for preparation of what? Ethers here. For the preparation of ethers. So what steps you have followed here? One is protonation. Second is attacking of nucleophile. Attacking of nucleophile, this one. Nucleophilic substitution reaction. SN2 mechanism. And after that, deprotonation. Deprotonation. So this is actually taking place in the preparation of what? Ethers. When you observe the textbook also, you will get same thing you will get here. You observe the textbook also, addition of H plus, right? Protonation, attacking of nucleophile, correct? Attacking of nucleophile, and deprotonation. Deprotonation. Now practice this mechanism. Okay. So definitely you will get the product actually. Otherwise, directly shortcut also you follow. Better to follow shortcut here because shortcut is very simple. Okay, but when you get 170 degrees Celsius, what happen? You are getting alkene, no? Okay. Now in that case, what happened? That never give what SN1 mechanisms here. So definitely what happened? You have to follow the SN2 mechanisms because by what I am saying here, the alkyl halide must be smaller group. When you get a smaller group in SN2 mechanisms only, this will be smaller actually. If it is larger, what happens? Secondary, tertiary, what happens? Then we get the elimination reactions. Okay. So you want to get SN1 reaction, they will convert into what direction here? Elimination reaction. Alkene we get here. Okay. Right. So secondary, tertiary alcohols, dehydration of alcohols to give corresponding what happened? Unsuccessfully. I will explain this one with sorry, just a wait, I will explain this. What they are saying here, you take primary alcohol, no problem. Like this you can take, or CH3, CH2OH, you can take, no problem for this one. Definitely we are going to get ethers. But if I take what tertiary like this, CH3OH. If I take this type of bulk groups, if I take like tertiary alcohol, here they are saying tertiary alcohol, okay, or secondary alcohols also. But I have taken tertiary alcohol. Now they do not form ether. Formation of ethers are very difficult. They are minor products or minor products. Now what they are getting actually elimination reaction, alkenes are forming. Alkenes. Just like 170 degrees Celsius. How we get 170 degrees Celsius? No, at 170 degrees Celsius, what we get here? Alkene. Understood? Very simple, I am saying. Primary alcohols, only what happened, what I am going to say in this case, primary alcohols. If I take primary alcohols, isn't it? I am writing here, primary alcohols, they can be converted into ethers at what temperature? 170 degrees Celsius in presence of concentrated H2. Sorry, 140. 140 it is. 140 temperature. 140 degrees. That means primary alcohols can be converted into ether at 140 degrees Celsius. But 170 degrees Celsius, we get alkenes. Correct? At 170 degrees Celsius, we get alkene. Or if you take secondary, tertiary alcohols also, you will get alkenes only. You don't get the ethers. This is the main point you have to understand. Understood everyone? Any doubts you are having in this one? By dehydration of alcohols? Have any doubts?
No, sir.
No, this already we discussed. You already we discussed this one, 309, 307, 390 like this, isn't it? Now the cleavage of CO bond ether. Let me see this one. This is the last thing. Let me see this one. Cleavage here. Only I will discuss the product. After that, what happened tomorrow? I will see the mechanisms. Now, before that, what happened? To try to complete this nomenclature. Today exercise is what 11.1 IUPAC nomenclature. Try to complete this one. 11.2. This one also 11.3. Now already we discussed 11.4 also. Explain why propanol having high boiling point than hydrocarbon because of hydrogen bonding. You can write here. And alcohols are more comparatively soluble when you compare with this is because of hydrogen bonding. In both the case, the answer is what? Hydrogen bonding. Hydroboration oxidation, this is not here. This is not here. This is there in the alcohols. It is in the alcohols, not here. This is not this chapter actually. Now give the structure of IUPAC names of monohydric phenols of molecular structures. This I will explain, no problem. T7H8O, I will explain this one. Okay. Already I think this is the, you remember one thing, already you completed, no? 11.2, 11.3 in alcohols, I think, no? The same, if you get any ether here, you write down this one. That means this is ether. This one is ether, this one is ether, this one is ether. Remaining are what? Already I think you completed. Where you have completed in the alcohols. Correct? Here also,
Yes, sir.
ethers are, where are ethers are there, you see here. Where ether is there? This one is ether. Okay. This one is ether. You select that ether groups actually, right? Wherever ether is there, you write down it. Next, have you completed everything? 11.8. Dehydration of ethanol. Last class we discussed this one. This part you have to complete. 11.24 is a very, very important. Everyone must do this one. 11.24. Everyone must do. Which method you are following here? Williamson synthesis we have completed. First of all, you write the structures here, all structures. Shall I explain one thing here? Which one you want to explain? Otherwise, you will do. Don't write the answer. Write the reaction. I want reaction. Don't simply what happened, seeing by what happened, NCERT solution. Just don't write the answer here. Shall I take what happened? Which one? 2-methoxy, 2-methyl propane. Shall I take 2-methoxy, 2-methyl propane?
Yes, sir.
First of all, you have to make a structure like this. All of you make a structure here. 2-methoxy, 2-methyl propane. 2-methoxy, 2-methyl propane. Let me see now. Two methoxy, 2-methyl propane, no? 2-methoxy, 2-methyl propane. Oh, just a minute. 2-methoxy, 2-methyl propane. Right. Now this one is alkoxy part. This part is alkoxy part. This part is alkane part. So part first you take oxygen like this. Now the alkane, the root word is propane. So you put like this. Carbon, 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 propane. Second carbon is having methane. Correct? Now put bonds like this. Now here it is a methyl group and here it is a methyl group. First carbon, second carbon, third carbon. So 2-methyl, now 2-methoxy. 2-methyl, 2-methoxy. Already we completed or not this one? Tertiary butyl, methyl, ether. Just now we complete or not?
Yes, sir.
Now what is the reactant you have to take here? CS3, Br plus CS3, 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 ONE. Because this must be, the bulk group must be Na, small group must be halide. Correct or not? You take one more example, so I will take one more example. ethoxybenzene. Take one example, ethoxybenzene. Now, ethoxybenzene means I can write like this, ethoxybenzene. Ethoxybenzene, CH2CH3. Now, whenever if we get a benzene beta, the benzene is a bulk group, not only bulk group, benzene we get what happened, that must be alkoxide. That must be phenoxide. So what we are take like this. ONA, correct? ONA, sorry. ONA plus this will be what, bromine CH2 CH3. Now NaBr is removed here. Now what we are going to get, this product, correct? So whenever if we get phenyl in the ether, that must be what, phenoxide. That must be phenoxide, sodium phenoxide, right? Understood here? Remaining can you do? Remaining one. First one, second one is very, very simple. Remaining is very, very simple for you. Now 11.25, illustrate the example, the limitations of Williamson synthesis for the preparation of certain types of ether. Just now what we discussed, same thing. This part only they are saying here. Limitation. Okay. So this is about what? Exercise, right? Remaining, we'll see. Now. Now when you observe here, only I will discuss here cleavage only. The mechanism we will discuss tomorrow. So we have only 5-10 minutes only left. So I will take only what? The cleavage I will take. CO bond cleavage. That means if I write like this, CH3, O, CH3 effect. You can cleave here. Or you can cleave here. CO bond cleavage they are asked. This is nothing but what? CO bond cleavage, right? Now, in this case, what happened? Whenever CO bond cleavage is taking place, that means ether is reacting with what? HX, hydrogen halide. Here X equal to what we can write here? Iodine, bromine we can take. Mostly we can take iodine and bromine, right? Now we are going to get cleavage like this. Now how you are getting? I'm writing it. ROR, okay? Sorry. ROR. Which bond I'm cleaving? CO bond cleavage. Now here, if I write HI here, if I add HI here, okay, HX, nothing but HI, one will get hydrogen, other will get iodine. So what we get here, ROH plus RI you are getting, R iodine you are getting. Alcohols you are getting, and alkyl halides you are getting. See here, alcohol you are getting, alkyl halides you are getting. Correct or not? For example, you take like this, CH3, okay, OCH3 I have taken. Now treating this one with HI. Correct? Now break this bond here. Now put here one hydrogen, put here one iodine. Now what we get here? CH3OH plus CH3I. Okay. But if you take excess amount of HI, I have taken second molar, first mole I have taken. Now if I take what second mole of HI, this one will react with second mole of HI, right? Now what happened? This OH and hydrogen will be removed as a minus water here, and this iodine will attack here to give what? CH3. So what I mean to see is that here, when ether, ROR, isn't it? ROR reacting with only 1 mole of HI, 1 mole of HI, we are getting alcohol and we are getting alkyl halides, right? But if I take ethers are reacting with what? 2 moles of HI, excess 2 moles of HI. Now in this case, we get 2 moles of RI plus water you are getting. Both are what? Alkyl halides. So here we get many number of examples we get here. This is the order of reactivity. HI is having more reactive, isn't it? Now here many doubts also we get here. If it is unsymmetrical ether, if it is unsymmetrical ether, what happens here? So this is the mechanism is given. So I will explain by taking a slide here. Now if it is unsymmetrical ether like this, CH3 O CH2 CS. I have taken only 1 mole of HI. If I take 2 moles of HI, no problem. Only 1 mole of HI if I take it. Now there is a chance of like this. CS3, you may get like this. OH plus CS3, CH2, iodine. Or you may get like this also. CS3 iodine or CS3, CH2H. If I take only 1 mole. Correct or not? Understood this one? Any doubts? That means you can cleave here to get your hydrogen, to get your iodine. Otherwise, you may cleave here to get your OH. Sorry, if you cleave like this, here I am cleaving. Yes, here I will cleave. If you cleave here, what happened? Now you may get here what happened? Iodine, or you may get here what? Hydrogen. Understood this one? Anybody? Any doubts you're having? Writing these products. This is the first combination. The second combination. Now, which one is the correct one? That is important for us. Are you there?
Yes, sir.
Understood? Which two combinations are getting or not? Understood?
Yes, sir.
Yes, sir.
I want to explain again. CS3, O, CH2, CS3. Here, what I am doing here, I am cleaving here. I got your hydrogen, I got your iodine. This is the first combination. First combination you see here, this one. Second combination, if I do something like this, CS3, O, CH2, C, because we are cleaving CO bond actually. I am cleaving here. Now we get here iodine, you will get here hydrogen. This is getting what actually second combination, this combination. Correct or not? Understood?
Yes, sir.
Now here, what is the main thing here, and why I'm repeating this one, which one will be major product here? First combination or second combination? That is important. So in that case, what we'll see here, whenever iodine attacks less number of carbons, less steric indents, that will be the major. Now you observe here, iodine attacking on more number of carbons, iodine attacking on less number of carbons. So second will be what here? Major product. This will be major product and this will be minor. So this mechanism we'll discuss tomorrow, not today, because it takes some time actually. Okay. So how this is possible, we'll discuss tomorrow class. Next thing, one more reaction, very simple reaction I will explain here. If I take what like this, if I take OR group, like whatever it may be OR. Now in this case, if you take 1 mole of HI, okay, now where we have to only one combination will be there. You can't break this bond. Always you have to cleave this bond, put your hydrogen, put your iodine. Definitely we are going to get the phenol. So whenever if you take phenoxy alkyl ethers, the compound you are going to get the phenol only. Anything if you take here, definitely you are going to get RI. Understood this? Why? Because here, what is the reason behind this one in this case? So if you write like this, OCS3, now the lone pair of oxygen and pi bond is in resonance. They undergo resonance to give double bond character. They will give some double bond character like this. And this bond will be shifted over here. You get a negative character here. Now we are getting a double bond character. Now you have to cleave what happened here, double bond now. Cleaving double bond is difficult, no? Cleaving double bond is difficult, but cleaving this bond is single bond is easy, no? This is very easy for us because how many bonds you are cleaving actually here? How many bonds you are cleaving? Only one bond you are cleaving. But here, how many bonds we need to cleave here? 2 bonds because of partial double bond character. So that is the reason we always get this type of only one combination we get. If you have phenyl group on ether, definitely one combination is possible. Understood here? So this they are actually mentioning here. If you observe this one, you observe here this one. Where you have to cleave compulsory? Only have to cleave here only. You can't cleave here. This is not possible better. This is not at all possible. Right? This is only possible. So compulsory you are getting phenols. So in this case, the product will be phenol. Okay. The mechanism we'll discuss, this part we'll discuss tomorrow. Right? This part We'll discuss tomorrow. Tomorrow we'll easily finish this ether. Tomorrow we'll finish this chapter. Right? All of you please wait because I will take the attendance. Don't go away. Because I will take attendance here because 2 members were absent, I think. Amrita is there. Next, Anupama, Anjusha, Neha S. Neha S is there. Neha S absent, I think, no? Neha S. Neha M is present, Neha S is absent. Nidhi, yes. Pradnya, yes. Radhika, yes. Rani, Samiksha, Samrin, Shivani. You are. Shivani is absent. Right? Shivani is absent.
Yes, sir.
Shreya. Both Shreyas are there. Yeah, yes. Ali, yes. Vaishnavi, Belgaonkar, Vaishnavi K, all Vaishnavis are there. Vanita present, Varsha present, Bhujbal Dhruv. Yes, Devashish absent. Patil Devashish. Devashish absent, I think. Devashish absent, no? Devashish is not visible. Hari Om Patil. Kiran. Nishant. Tejas.
Yes, sir.
Venkatesh. Vinayak. Anupama is there. Bhuvaneshwari is there. Neha M is there. Nikita. दो निकिता रहते हैं ना. Both. Nikita Kadolkar. What about second Nikita? Nikita T. Where is Nikita T? Absent. Pranali. Yes. Rohini. Rohini is there? Rumali Rohini. Rumali Rohini absent. Samruddhi. Shreya present. Deva present. Parth present. Patila that's present. Priyanshu present. Nikita Talawar absent. Okay, 4 members were absent today. If you have any doubts, you can stay with me, otherwise you can log out.